right, so our last section, we're going to look at 5.3 again. Okay, just part 2. So yesterday we learned how to write a complex number in polar. And the advantage to writing it in polar is it gives us an extremely fast way to multiply and divide complex numbers. All right, so normally we just went through this, but when you divide, okay, you have to find the conjugate. You have to multiply by on the top and the bottom. So that involves foiling things out, combining like terms, changing I-squareds to -1s, separating into 2 fractions, and then reducing those fractions. Okay, all of that is going to go away. Okay, it's going to be extremely simple to divide complex numbers or multiply in polar. Right, so I'm going to suppose we have 2 complex numbers. Okay, I'm going to call them Z complex number 1 and number 2. Z1, Z2. Each complex number is going to have its own radius, okay, which when we do an actual problem, there'll be numbers. I'm going to call my first radius and my second radius. And each complex number has its own angle, okay, which I'm calling θ1 and θ2. First angle, second angle. And I'm going to show you the formula for the product first, okay, how we'd multiply them. Okay. Normally, this is where we would start doing FOIL. Okay, so if you had, just show you an example, this times this, now we would start doing all of this out. We're not going to need to do this at all. If you want to multiply these 2 complex numbers, as long as they're already written in polar, all you have to do is take the 2 radii, okay, take the numbers in front, multiply them together. Okay, so take whatever R1 is, whatever R2 is, multiply them. And then look at your 2 angles and add them up. Okay, whatever θ1 is, add it to θ2, and that's your new angle. And that's it. That's all you have to do to multiply complex numbers in polar. Multiply the 2 radii, add the 2 angles. Okay, you're not going to have to worry about any of that other stuff you had to do when we FOILed. All right, so let's try this one. Okay, they can call the complex numbers whatever they want. Okay, if they want to call them Z1 and Z2, they could call them A and B, Z and W. It doesn't matter what they call them. Okay, we just have to focus on the 2 radii and the 2 angles. So if we want to multiply these together, first step is to multiply my 2 radii. What would I get when I multiply my 2 radii here? Yep, you're going to get 15. 3 times 5, 15. And the last step, look at what your 2 angles are and add them up. 120. And that's it.
We don't do anything with imaginary? Oh, it comes up. Right?
Yep, the imaginary part is right at the end. Any questions on that? A lot easier than doing all the foiling and I-squareds and all that stuff. The only thing is you have to have your numbers in polar. So if you wanted to do a problem like this, I think it would probably be quicker to do it by foiling. By the time you change this to polar, change that to polar, and then do what we just did, I don't think you're going to save time. But if it's in polar for you already, that's a huge advantage. All right, let's try this one. Okay, this time my first complex number is 1/2 cosine 15, I sine 15. Second one, 10 cosine -30, I sine -30. Okay, when I multiply those together, what is my radius?
10.
What is it?
Oh, yeah. 5.
5, yep. Take a half,
My bad.
take 10, multiply together.
15.
And what's my angle? Negative 15. Okay. First angle is 15. Second angle is negative 30. Add them up. Negative 15. Right. Now I showed you two ways we can get rid of a negative. Okay. On the tests, they're probably going to write the answers with a positive angle. So what's something I could add to that number to make it positive? You could add 360. So what would this angle be as a positive? 345. Yep. And I'm not going to go through the second way you can make it positive. We don't have to worry about that. Any questions on that one? Okay, so multiply your radii, add your angles. Okay, that's from multiplying. Okay, now when we do dividing, the steps are going to be just as easy, but they're different we just have to make sure we keep them straight. Right, so suppose, again, we have the same two complex numbers. Okay, two different complex numbers. The first one has a radius of r1, the second one r2. First complex number, its angle would be theta 1. Second complex number, the angle is theta 2. We will know all those values in a real problem. Okay, so based on what we did last time, anyone think they could tell me what I'm going to do with R1 and R2 this time?
Divide.
We're going to divide them. And what do you think I'm going to do with my angles? I'm going to subtract them. Yep. So to divide two complex numbers in polar, which is what we're doing, take your radii and divide them, take your angles and subtract them. So much easier than doing the conjugate and all the other stuff. Okay, and on the test, you'll have, I think it's one of each. One multiply in polar, one divide in polar. Okay, we're going to do a divide in polar right now. Does everybody have the Z1, Z2 above it, the box? Right, so the directions are asking me to divide Z by W. Okay, it would be different if they said W divided by Z. That would be a different problem. So we just have to make sure we pay attention to how they want us to do it. Okay, when we divide Z by W, what is my radius going to be? 3/5, yeah. We don't even have to change it to a decimal. We can just write 3/5. And last step, what is my angle? 45, yep. That's it. Okay, so everything we just did right there just took the place of all that conjugate stuff we learned yesterday. So you might say, well, why didn't we just learn it this way to begin with? Because if you already have a point in rectangular, I think it's going to take you longer to change it to polar and do it this way than it would be to just use the conjugate. So it depends how they give you the problem. If they give you the problem in polar, I would do it this way. If they give you the problem in rectangular, I would just do it this way. Okay, so it depends on what way they give it to you. Any questions on that one? All right, let's try one more with division. In this one, it says z is 10 cosine 20, I sine 20. And w is the complex number 1/2 cosine 100 plus I sine 100. Okay. Austin, what two numbers am I going to divide to find my radius?
10 and 1/2.
Right, we're going to do 10 divided by a half. Okay, so be careful when you think about that. What's 10 divided by a half? Not 10 divided by 2. 20, yep. So 10 divided by 1/2 is 20. And what about my angle? We don't have to make it positive yet. It's going to be what? It's going to be negative 80. So I'm just going to write that up here for a second. And how would I make negative 80 positive? Just add 360 to it. Okay. So I'm going to write my angle as 280. Any question why I'm using 280? You don't have to do that if they don't say to make the angle positive, but in case they do ask you, I want to show you how to do it. All right, so 20 cosine 280, I sine 280, and you're done. Okay, questions on that one? All right, so we looked at multiplying, we looked at dividing. The last thing I'm going to show you, which is a nice shortcut, just as easy as these two, is raising something to a power. Okay, and the theorem we're going to look at is called de Moivre's theorem. That's how you say it, de Moivre's theorem. And let me show you how we would have to do this without this trick. Okay, let me show you how you'd have to do it in rectangular. Okay, so leave a little bit of space because I'm going to give you a formula in a box in a second. But I'm going to show you what it would look like without this shortcut. What does that mean to do if I said 1 plus 2i squared? How would I, like, let's say you had to explain it to somebody who doesn't understand exponents. You could say, oh, well, you could just write it this way and it means the same thing.
Would you have to distribute the 2 to the entire equation?
Yeah, when you have a 2 in front, that's when you would distribute. This is a little different.
You have to distribute itself, so you have to do kind of like we were doing before, instead of changing it. But you have, like, you have to multiply. I don't know.
You would multiply 1 plus 2i times 1 plus 2i.
Yes. 1 plus 2i
That's what I meant.
times 1 plus 2i.
Oh. I didn't understand.
That's all right. We get it. Now, that's not too bad. Okay, I can do it pretty quick. I get 1 times 1. I get 1 times 2i. Another 1 times 2i.
Thanks for having my back.
It's 4i. And what's 2i times 2i? 4i squared, which is negative 4. And then 1 take away 4? 3? Negative 3. Okay, so that's what you get if you do 1 plus 2i squared. Okay, we just did it out. Now, what if I wanted to do that? What does 1 plus 2i cubed mean? Again, pretend you have to explain it to somebody who doesn't understand exponents. You multiply it how many times? 3 times. So we have 1 plus 2i, 1 plus 2i, 1 plus 2i. Well, I already know what 1 plus 2i times 1 plus 2i is. I just did that up above. That's negative 3 plus 4i. just did this part up above. Okay, as Kate just said, you got to do it one more time. Okay, and if I do it out, what's negative 3 times 1? Negative 3. Negative 3 times 2i? Negative 6i. 1 times 4i? 4i. What's 4i times 2i? 8i squared, which is negative 8. Now I got to do negative 3 minus 8. It's negative 11. And what's negative 6 plus 4? Negative 2i. And so even cubing it, it's not that bad. I can do it, but it's starting to get a little time consuming. Okay? Let's say I had something like this.
Never mind.
All right, now to do that out, it's not hard, but it's going to take me a very long time, and the chances of me making a mistake somewhere are pretty good. Well, with this theorem, I can do this problem, that problem, or even that problem just as fast. It doesn't matter what you give me as an exponent. Okay, so I'm going to show you the trick, okay, to do this out faster. So the trick, if you want to raise a complex number to a power, you raise the radius to the power. Okay, that's step 1. Raise your radius to the power and multiply your angle by the power. And that's it. You're going to raise your radius to the power and multiply your angle by the power. Okay, so we're going to do one that's to the 8th power. Okay, 8th would be pretty time consuming, not the worst, but it'd still be pretty bad to have to do that the long way. You'd have to write this out 8 times and then FOIL everything together. Okay, well, now let's use our shortcut. Okay, I want to take and raise all of this to the 8th power. So what is my radius going to be? Yeah, take your radius and raise it to your power. R raised to whatever power you're working with. Okay, so as Kate just said, 3 to the 8th. And what about my angle?
60.
How'd you get 160?
20 times 8.
Yes. Multiply your power times your angle. Take your power times your angle. 20 times 8, 160. And you're done. Much shorter than having to multiply something out 8 times.
You don't want us to do like that 3 out. To the 8th power.
Let's see how big it is. Okay, if this number starts to come out too big, like in the millions, we're not going to do it out. Okay, 3 to the 8th power. That's not huge, but I'd say let's just leave it as 3 to the 8th.
Sounds good to me.
Okay, let's say you had something like 2 to the 8th. That would be much smaller. I would say write 256.
Okay, so up to like 3.
If it's in the hundreds, yeah. If it starts to get in the thousands and millions, we won't write it. See how much time that saved versus trying to do it out this way? It's much faster. Okay, so now we've got 3 tricks for working with numbers in polar. We've got a quick way to multiply, a quick way to divide, and a quick way to raise to a power. We don't need a quick way to add and subtract. I would say when we're adding and subtracting, if you had this plus this, it's already pretty quick to just say 2 plus 4 is 6, 3i plus negative 2i is I. I mean, can't really get much faster. Okay, so adding and subtracting, we're not going to learn any new tricks. We already have a good method for that. Okay, so one mistake people make on the test is they see a problem like this, and they start doing this. What's wrong with what I just did there? That's multiplying, right? You don't FOIL anything if there's a plus or a minus sign. You're just combining like terms. Okay, so people will FOIL this out, get an answer, and say, my answer is not on the test. and I'll tell them they're doing something wrong. Okay? So just make sure you understand add, subtract, multiply, and divide.
So this one, there is going to be multiple choice.
Most of it is multiple choice. There are some that are not. Okay, when I have you graph a point,
Yeah.
that's not multiple choice. All right, so the homework for tonight, it's on 333, same page as last night. It's 33 to 37 odd, 41 and 42. Do not follow the directions they give you for 41 and 42. Okay, I'm telling you to leave the answer in polar. They tell you to do something else, don't do it. It's not going to make sense. Okay, so 33, 35, 37, 41, 42. Okay, so you got about 20 minutes. Okay, so please try to get started. If you need any help from yesterday, let me know. Okay, I'll also be here after school today for extra help.